Alrighty guys, today we're going to be talking more about adding and subtracting fractions. The first examples that we're going to be focusing on are just basic fractions when there's just a whole numerator and just a denominator. So when I'm looking at the fraction 4/6 plus 3/9, just like I talked about in the previous video, our first job is to make sure that we're finding our LCM. So in looking at our denominators, 6 and 9, they are not the same. So we cannot add them yet. So if you look on over to my example, I looked at my denominators, 6 and 9, and I listed my first 5 multiples. So 6, 12, 18, 24, 30, 9, 18, 27, 36, 45. I looked for the one that they had in common, the lowest common multiple, and that is 18. And that's why I circled it. So if I'm coming back to my original problem, 4/6 plus 3/9, I need to think, how can I make my denominators, 6 and 9, have the denominator now of 18 to make equivalent fractions? So I need to multiply my denominator of 6 by 3. So 6 times 3 is 18. So what I do to the bottom, so multiplying it by a 3, I need to do it to the top to make sure that they're equivalent and staying balanced. So 3 times 6 is 18, 4 times 3. Same thing with the new fraction of the 3/9. I need to think, how can I make this 9 a denominator of 18? Well, I multiply it by 2, and that can be seen up here. It is the second multiple. So what I do to the bottom, I do to the top. So if I multiplied the bottom denominator by 2, I need to also multiply the numerator by 2. Which brings me to my next and my newest fraction. So 4/6 turns into 12/18, and 3/9 turns into 6/18. So when you are adding or subtracting fractions, it is super, super, super important that you are just adding the numerators. You are just adding the top number. The bottom number, the 18, now represents how many pieces are in the whole. So Miss Corso has 12/18 of a cake. I ate 6/18 of the cake. How much did we eat in total? 18/18, because our denominator stays the same and our numerators add together to be 18. So 18/18, which coincidentally is one whole. If we were to look at this next example, which is 6/7 minus 2/3, very similar to what I did for addition of fractions, I need to look at my denominators. They're not the same, so I cannot add them yet. So I'm going to scooch over here where I wrote my first 5 multiples to find my LCM. So for 7, I have 7, 14, 21, 28, 35. For 3, I did 3, 6, 9, 12, 15. There wasn't a common multiple yet, so I had to keep adding on more multiples to my 3s to then get my new LCM of 21, which I circled. Bringing it back to my problem, I thought, all right, how the heck am I going to make my new denominator be 21? Well, I got to multiply, of course, and create equivalent fractions. So I took my 7, my denominator right here, and I multiplied it by 3. So what I do to the bottom, I do to the top. Same thing with this 3 over here. I looked at this 3 of the 2/3, and I thought, how the heck am I going to turn this into a 21? And I said, all right, I'm going to multiply by 7. What I do to the bottom, I have to do to the top to make sure I'm creating those equivalent fractions, making sure everything is staying balanced. So my fraction once was 6/7 minus 2/3, and now it is 18/21, or 18/21 minus 14/21. Alrighty, so very similar to when I added or when I was adding fractions, when you are subtracting fractions, you are not touching the denominator. The denominator is staying there. It is cemented because that's how many pieces we have in the whole. And in this case, there are 21 pieces in our whole cake. So I had 18/20 over 21, and I'm taking away 14/21 to give me 4, which is my new numerator because I'm subtracting 18, and I'm taking away 14 and my denominator of 21. Great job, guys. Definitely keep in mind when you are adding or subtracting fractions, it is so important for you to be listing your least common multiples, creating your new equivalent fractions, and you are not at all touching your denominators. just your numerators.